Okay, so subtracting mixed numbers. This is a follow-up video to the video on adding and subtracting mixed numbers. And it's here to highlight a particular issue. And here's an example that gives us that issue. Let's start with 4 and 1/3 minus 1 and 2/5. Okay. And we talked in the other video about how we could subtract mixed numbers by actually separating the whole numbers and the fractions and subtracting them independently of each other. So here that would give us 4 minus 1, which is 3. And then we'd do our 1/3 minus 2/5 separately. And we remembered that to multiply fractions, to subtract fractions, we'd be looking for a common denominator. We're looking for the lowest common multiple of 3 and 5. And if we look at 3 and 5 and think about numbers in the 3 and 5 times table, we come to 15 quite quickly as a number that's in both those times tables. So we can change both of those fractions to fractions over 15. We times 3 by 5 to make 15, so we do the same thing to the numerator. 1 times 5 is 5. And 2/5, we times the denominator 5 by 3, don't we, to make 15. So we do the same thing to the numerator. 2 times 3 is 6. And this is the issue that we come to sometimes when we're subtracting mixed numbers. We are left with 5/6 minus, not 5/6, 5/15 minus 6/15. And clearly we have a situation where the second number is bigger than the first number. And when we are 6 years old, we're trained to say, oh, can't do that. Of course, you're possibly a little bit older now, and you're understanding that there is such a thing as negative numbers, but you don't want to end up with a number like 3 and minus 1 over 15. That doesn't make sense, does it really? You can't have a mixture of a positive integer and a negative fraction in the same mixed number. So we need to do it better than that. So we need to think about how we can do 5/15 minus 6/15. I can offer you a couple of ways, and the first way, I think, is probably the approved way. But the first way involved borrowing, just like you would have done, just like you were taught to do when you were younger. Remember sums like 15 minus 6? You'd write them out like so, wouldn't you? Dum-de-dum-de-dum, 15 minus 6, write that like that. And you'd start in the units column and you'd say, okay, 5, take away 6, I can't do it. And you were taught to borrow. You were taught to go to the next column and say, can I borrow one from here? And of course there is one there that you can borrow, so you take it away and you pop it in front of your 5 to make 15. And then you say 15 minus 6, I can do that, that's 9. And so your answer would be 9. But we're going to do the same thing here. We've got 5/15. We want 5/15 to be bigger than that, so we can take 6/15 away. Where can we borrow from? Yeah, of course, we can borrow from our whole number. If we take 1 away from our 3, that leaves us with 2. And we'll put it, the one that we borrow, with our 5/15. So we get 1 and 5/15. Take away 6/15. That's still not hugely helpful to us. So what we'll do is we'll turn that 1 and 5/15 into a top-heavy fraction. 1 times 15 is 15, plus the 5 makes 20. So 1 and 5/15 is equivalent to 20/15. That's a top-heavy fraction. And now that we've done that, let's just show you that, of course, is the same as that, isn't it? Excuse the sort of squiggly lines today, I've got a bit of a problem with the board. 1 and 5/15 is equivalent as a top-heavy fraction, so 20 over 15, and now we can of course do 20 minus 6, that's one we can do. 20 minus 6 is 14, so we're given an answer of 2 and 14 over 15, 2 and 14/15. So that's one way in which you can deal with this situation that we had here, where our first fraction was smaller than the second one. You want to see a different way of doing it? Here is the same problem. Yeah, this all depends how comfortable you are with negative numbers, really, and using them. Because, of course, 5 minus 6 is minus 1, we here have 3 and minus 1, 15. So we wouldn't leave our answer like that, but if we understand that this is the same as whatever we get when we do 3 take away 1/15, then we can begin to understand why the answer is the answer we just got. Here are three pizzas. It's always pizzas. I don't quite know why the word pizza squiggled today, but there we go. Here are three pizzas. I'm dividing them in 15ths here. Obviously these are not 15ths, these are representations of 15ths. Okay, this is my 3 right here. Okay, 1 plus 1 plus 1. That's my 3. 3 whole pizzas. If I take away 1/15, then I will still have up here, I have my 1 and 1, and here in my third pizza, having taken away that 1/15, I have 14/15 left. Which is why, or how, I end up with 2 wholes and 14/15. So an alternative way of dealing with a situation where the second fraction is bigger than the first fraction is to subtract them. Do 5, take away 6, and get your answer of -1, and then take your 1/15, in this case, away from whatever your integer is, in this case 3, to leave you with this answer here. 3 wholes minus 15, leaving with 2 wholes and 14/15. There we go, that's an alternative way. So method number 1 is to do our borrowing, the old-fashioned way. Take something away from the whole number here to make our first fraction bigger than the second fraction. And the second method was to subtract the fractions and to get a negative number answer, and take that negative fraction away from our whole number. Let's work another. Let's do that again with another problem. 7 and 1/5. Fifths again. Take away 3 and 3/4. Here it is. Okay. So we take away our integers first. What's 7 minus 3? It's 4. So we have 4 and 1/5 minus 3/4. Okay. We find a common denominator for our two fractions. Well, if we count through our 5 and our 4 times table, we get to 20 when we find our first number that's a multiple of both. So we'll use 20 here. 5 times 4 is 20. So 1 times 4 is 4, and 4 times 5 is 20. 3 times 5 is 15. So there's that same old problem. We have 4 over 20. Take away 15 over 20. So the first number is smaller than the big number. The first fraction, sorry, is smaller than the second fraction. Let's borrow again. We'll borrow 1 from our 4, so leave 3. And we'll bring that 3 down here. And the other one that we've got, we'll put here with our 4/20. 3 plus 1 is 4. 1 and 4/20. Take away 15/20. Let me show you what's going on. Then we'll turn our 1 and 4/20 into a top view fraction. 1 times 20 is 20, plus 4 is 24. So we've got 24 over 20 minus 15 over 20. And now, of course, we've got a sum we can do. 24 minus 15 is 9, so we have 3 and 9 over 20. Okay, so there's your answer. Let's see how that works the other way. Let's just work from this section here. So we had 4 and God, what's up with the 4 today? 4 and 4 over 20 minus 15 over 20. Okay, well let's use our negative numbers. What's 4 minus 15? 4 take away 15 should be negative 11. So negative 11 over 20. So if we start with 4 wholes and we take away 11/20, well, we're certainly going to have 3 wholes left, aren't we? And if we have a whole pizza, if we divide it to 20ths and we eat 11 of those 20ths, take 11 of them away, how many 20ths will we have left? We will, of course, have 9 more 20ths, because 11 and 9 makes 20 20ths together. So there's your answer there, and would you believe your answers are the same? So I'm not doing something right, or I'm not doing it wrong the same way both times. That is how you can deal with subtracting mixed numbers where your second fraction is bigger than your first fraction. You can either go the borrowing route, which is the way kind of the way you learnt when you were a kid, hey? Or you can, if you're comfortable dealing with negative numbers, you can go this route here. Two perfectly simple methods, I reckon. Good luck with them both.